Okay, welcome students. In this lesson we're going to work our way through chapter 19, okay, which is on functions. So we're going to jump straight in to section 19.1. And the thing is, what is a function? A function is a mathematical construct where an input, for one input there's always one output. So this is a depiction of that. For every input there's going to be one output, and it's a very clear mathematical rule, possibly a simple rule like add 4 subtract 3, or a more compound rule like multiplied by 5 and take away 4, or something like that, which would be linear, or it could even involve squaring, which would be quadratic. So let's take a look at a simple one. The rule is to multiply by 4. You drop in 7, the input, and at that stage 28 would come out. But if the rule then also included to add 1, you'd end up with 29. So 28 would be your interim value here. Okay, so this would be a compound function as such. Okay, let's see, is there anything very different? Well, of course we can replace 7 with what we call the variable, or the dummy variable, which is x. So now when we multiply by 3 we get 3x, and when we add 2 we get 3x plus 2, which would be the y value if we're plotting it. So we would have f of x or y going up, and we would have x coming out, and we end up getting a curve, of course, in this case a straight line curve for this one. Okay, and there's another one, 2x plus 4. Quick recap on what this means. It means our intercept, this value here, is 4, and our slope is 2, going up 2 for every one out, and so on. So we can jump straight into the exercises. I'm going to take the book off screen now and just work through the exercises from the side like you might do at home. Okay, so here we are. Actually, I'll see, could I keep both on picture? It might be better for you. So find the output for each of these, where 8 is put into a function that subtracts 6. So so we're going to go with question 1, page 443, and when 8 goes in, subtracting 6, what comes out? 2. So the input is 8, the output is 2. Here we have a more compound function, times 2, the 5 is 10, add 1, we output 11. Divide by 2, the input 6. This would look like x over 2 plus 3. Just to preempt where we're going with function notation, it would look like this. You put in 6, you divide by 2, and you add 3, giving you 3, and 3 is 6. Okay, put in 4 and multiply by 4, you'll get 16. Put in 3, multiply by 3, you'll get 9. Now subtract 4 from the 9, you'll get 5. Put in 10, input of 10, f of 10, subtract 5 is 5, multiplied by 3 now. I just want to say what that would look like. F of x equals x subtract 5, oh no, apologies, f of x equals x subtract 5 multiplied by 3 then. Okay, so that would involve a bracket, and let's do it. Subtract 5 is 5, now multiply by 3, it's 15. Okay, hope we're doing well here and you're following along. And of course, pause or take a break anytime you like. Describe in words what each function machine does to the input in question 1 above. Okay, so in words, the function subtracts 6, multiplies by 2, and then adds 1. This function divides by 2 and then adds 3. This function multiplies by 4. This function multiplies by 3 and then subtracts 4. And this function firstly subtracts 5 and multiplies the output of that by 3. And that's where the bracket comes in there. Okay, find the output for these. So when we put 3 in, we get 6, subtract 4 is 2. When we put 7 in, we get 14 at this stage, subtract 4 is 10. When we put 8 in, we get 16, subtract 4 is 12. When we put put 2 in to add 4, we get 6 times 2, 12, 5 times 2, 10, naught in, now we have 4, now we have 8. Okay, so this is a function machine, and we can also have a graph with y or f of x here. Okay, so let's use the table. We drop 1 in, so there's our variable x, which means take all these values for x and see how you get on. Put 1 in, we get 3, 3 is 9. Put 2 in, we get 4, 4 3s 12. Now the pattern will arise, especially if we think of the function as x plus 2 times 3, or 3x plus 6 if we expand that. Okay, this is connecting our maths to other parts of maths, which is a good thing to do. And so what we're having here is we're having a slope or an increase of 3 every time. So I can keep the pattern up, 15, 18, 21. Write in words what this function machine does. Adds 2 and then multiplies everything and multiplies the answer by 3. Okay, so it's important that this then be prioritized with brackets. Okay, so write the rules for these functions. Now I will say that writing them in words is somewhat more challenging than writing them in algebra, but it does say, and I'm not too sure, let's just check the back of the book, would write the rules be write in maths or write in words? It doesn't really specify, so I just have to, there's no way of knowing really without checking the back of the book. I don't want to make a mistake and set you wrong. 19.1, looking at question 5. Yeah, it's doing it in algebra, which is great, so that's what I said would be easier. So multiply by 2, we have 2x, and now it wants me to add 6. And between priority of operations, then we don't need a bracket on that one. X divided by 4, and we really do prefer in algebra the fraction bar, x divided by 4 over the divide symbol. So I'd subtract 3. Okay, multiply by 8, giving us 8x, subtract 9, add 3, so we have to x plus 3. Now in this case, we need, because multiplication comes, if I just put a 4 here, multiplication would happen before the addition, but we see here the addition happens first. So in order to make addition prioritized, we must use a bracket. Okay, and we have 4 times that. Find the missing operation. Well, okay, this is kind of interesting, but at least we have 3 examples so that it's most likely, because sometimes there's more than one answer to these. So 3 turns into 15. It's either add 12 or multiply by 5, but we'll get it from the second one that it's multiplied, and the third one that it's times 5. So and if it's the missing operation, it's 5x. Okay, here we're adding 4, so it's x plus 4. Check a few of them. It might be divide by 4. It looks like divide by 4. It is divide by 4, so we'd say the function is x over 2. Okay, question 7. Find the missing operation for these functions. So it's giving us part of it. You multiply by 2 to 6 and you end up with 5. It's probably take away 1 here. You multiply by 2, yeah, it certainly is take away 1. So take away 1, or all told it's 2x minus 1. We're not going to multiply by 3, so we know we're at 0, and then we end up at 1. So probably a plus 1 here, but let's check. We're not sure of that yet. Multiply by 3, we get 3 and 1, yeah. Multiply by 5, we get 15 and 1, so it certainly is plus 1, so this was 3x plus 1. So I'll break the videos up into sections, so I've only one last bit to do it fully. What numbers went into each of these function machines? So, okay, so this is the most challenging question so far. But let's just approach it by getting our hands dirty and thinking out loud and seeing where it takes us. So let's work our way back from the end actually. So let's say before adding 1 we were at 10. We multiplied by 2 to get 10, so 5 must have gone in. Back over here now, 17 take away 1 to the inverse operation here is 16. We have multiplied by 2, so 8 went in. 41 turns into 40, had multiplied by 2, so 20 went in. 10, something multiplied by 3, ooh, this is a tricky one. Oh no, subtract 1, I almost did it wrong. So the inverse operation of subtract 1 is add 1, I'm at 12. After multiplying by 3, I'm at 12. So inverse operation of multiply by 3 is divide by 3, so it's 4. Subtract 1 is add 1 going backwards, 23, 24, divide by 3 is 8. 29 inverse of this is add 1, 30, divide by 3, 10, 4, 8 and 10. Okay guys, so that's the end of section 1. I'm going to send you a video for all the sections of the 3 functions chapters. So and we'll put them into their own playlists on YouTube. So what I have here is 19, we'll do chapter 20 and we'll do chapter 23. Okay, and hopefully if that's going well, we can do it for the entire book just to help you. As always, we'll see you in the next one.